I find it very funny how you can make so many different variations of a specific problem. Just a staircase, right? And there are so many ways that you can jump. I am talking about the problem Jump Game 3 on LeetCode. And you will be surprised, this problem can be solved using the tree data structure. So let's see what we can do about it. Hello friends, welcome back to my channel. First, I will explain you the problem statement and we will look at some sample test cases. Going forward, we will see how you can actually attack this problem. It is a little overwhelming at first. Going forward, we will see how you can convert this problem to solve using a tree data structure, and then as usual, we will also do a dry run of the code so that you can understand and visualize how all of this is actually working in action. Without further ado, let's get started. First of all, let's try to make sure that we are understanding the problem statement correctly. In this problem, you are given an array that only has positive integers, and each element represents how far you can jump in either direction. That means if I'm standing at this position, then I can either jump 3 spaces ahead or I can jump 3 spaces backwards, right? And given all of this, you are given a starting position, and then you have to determine if you can reach a step that has the value 0. Let us look at our first test case. I have this sample array. That means I will have my staircase something like this, right? And this time you are also defined a starting index, that is 5. So based upon a 0-based indexing, you have, correct? So when you say starting index is 5, that means where are you standing? You are standing at the step which has the value 1. So technically, I am standing right over here, correct? According to the problem statement, you can jump in either direction based upon this value. So this value is 1. So either you can jump 1 step in the forward direction or you can jump 1 step in the backward direction. If you're jumping forward, you will land at 2. If you're jumping backward, you will land at 3, correct? So that is what you have to do. Let us say you jump 1 step backward. Now I am at this position. Once again, you can either jump 3 steps forward or you can jump 3 steps backwards. If you notice closely, I can jump 3 steps backwards easily, right? I will land at step number 2. But if you try to jump 3 steps forward, there is no third step, correct? So the forward jump is not even possible. From this step, you can only go backwards. That is the catch. If you can jump a maximum of 3, that means you have to take that maximum jump. You cannot take either 1 jump or 2 jumps. That will be an entirely different problem. For this particular problem, what you will do is you will jump 3 steps backwards over here since you cannot go in the front. If you go back, you land over here. And then once again, you have 2 choices. Either you go back or you go in the front. If you notice, you cannot go backward 2 steps. You only have 1 step available, right? So you will try to go 2 steps forward. And if you notice, by taking 2 steps forward, I will land at 0. And that's it. I was able to arrive at the step with the index 0. So for my first test case, I will return true as my answer. Similarly, if you look at the second test case, I have this staircase, right? 30212. And where am I standing? I am standing at index number 2. Just notice that it is a 0-based indexing. So I am standing over here. Now, in this particular test case, there is no way at all that you can reach this step 0. You can try out all the combinations. Jump 2 steps forward, jump 2 steps backwards. If you are here, then once again you will reach this particular step. And if you are over here, then you are gonna reach this particular step. Then you will once again land at 2. So you will keep on repeating this. You will never be able to reach a 0. So for this particular test case, you need to return false as your answer. So that is all you have to do in the problem. You just have to tell me, hey, is there a way that I can reach the step which has a value 0? If yes, return a true, else return a false. You do not have to trace out all of these steps. Neither you have to determine what is the minimum number of steps required. So now if you feel that you have understood the problem statement even better, feel free to first try it out. Otherwise, let us dive into the solution. I have a sample test case with me. I have this array that is representing all of the stairs, and I have a starting index that is 5. So it simply means that I am standing at this particular position. As soon as you begin to solve this problem, it is quite overwhelming that, okay, how do I even begin solving it? The brute force approach is straight away out of the question, because that means you will find out all the different possible combinations from each of these steps, correct? You will keep on starting from the beginning and then try to see, hey, can I reach a zero? So it will end up taking a lot of time. It will work for smaller arrays, but for larger arrays, you will waste a lot of time. So how do you even begin to attack this problem? For problems like these, or some problems in general, it is often a good idea that you just try to trace out all the steps that are happening. And it might be possible that you will be able to visualize a particular solution. For this particular problem, where are you standing right now? You are standing at the value 1, right? And if you notice, whenever you have an array, you have two different pieces of information available. One is the array itself, and one are all the indices. So you can take advantage of it. What you can do is, you start off at the very first position, right? So this simply means that I am starting at the value 1 and at the index 5, correct? Now, according to the problem, what can you do? You can jump in either direction. So it means that you have two choices. Either you take a left jump or you take a right jump. Since you are at the value 1, you can only take a jump of one step in the either directions. So if you take a left jump, where do you land? You land at the value 3 or the index 4, correct? And if you take a right jump, then you land at the value 2 or the index 6. So once again, just write it down. Now, how do you proceed ahead? Just look at this left node, okay? So you are standing at this particular position. Once again, you will have two choices. Either you go to the left or you go to the right. If you are going to the left, you take 3 jumps, and where do you land? You land at the value 2 or the index 1. So just write it down. And what happens if you try to take a jump in the right direction? You see that you only have 2 elements. So a jump on the right direction is not possible at all. So you can simply leave out this particular condition. What happens next? You see that you have to compute for this particular position as well. And what was this position? In this position, you were standing at this particular index. So once again, you have two choices. Either you take a jump on the left or you take a jump on the right. You can easily see that a jump to the right is not even possible. You can only jump to the left. If you jump to the left, you land at the value 3 or the index 4. And you already know that the jump to the right is not even possible in this scenario, correct? So this is what gives you an idea how you can proceed with this problem. So you have computed all of these 3 positions, right? Now, what is the obvious next step? You will start up with this position, right? And for this position, where are you standing? You are standing right over here, correct? And once again, you have two choices. Either you jump to the left or you jump to the right. You cannot go to the left since you only have one place, but you can go to the right. So once again, I have two choices. You already know that you cannot jump to the left. So this value will be a null. And what happens if you jump to the right? You land at the value 0 or the index 3. So what just happened? You did it, right? You arrived at a index that has the value 0. And this is your answer, correct? So if you start to proceed this way, then while going through every step, if you arrive at a value that is 0, just simply return a true and that's it. You don't have to solve any further. So you can see that this is kind of a recursive approach, right? You have to go at each of the index and then look in both the directions. So this is a general idea how you can go about approaching this problem. But I often feel that recursion is a bit tricky. If you notice closely, what are we doing over here? We have this binary tree data structure, right? And there is certainly a neat trick that we can take advantage of. For this given test case, if you would have continued to expand this binary tree, this would end up looking something like this, right? And If you notice, this is a correct binary tree data structure. To arrive at our answer, we need to keep on traversing all of these nodes until we reach a node that has the value 0, right? If you're able to find a value 0, then yes, you can reach over here and you can return a true. So what are we doing over here? We are doing a level order traversal. If you're new to level order traversals, I would highly recommend you to stop this video right over here and watch my video on level order traversals first. As a quick reminder, what did we used to do? Let us say we have this sample binary tree. Then to do a level order traversal, we take up all of these nodes one by one. We start off with the root node and we will add this node to our queue over here, correct? Now we start popping elements from the queue and add their left nodes and the right nodes back to the queue. So I pop out this node and I will see what are its left child and right child. This gets popped out and I will add the left child and the right child in my queue itself. So that is how I know that, okay, I have covered one of the nodes. To proceed ahead, you will pop one more element from the queue. This time you're popping B and once again you will see what are its children. Its child is a C, so you add this node to your queue. You are done with B and that is how you know that, okay, you have traversed this element B. If you keep moving ahead, you take up the next element, that is D, and you will add its nodes to your queue. Now you know that you have taken care of D, so D will get removed from the queue and you have traversed D as well. So this is how a level order traversal is actually working. So that is all you have to do. Just utilize this array and take the help of an additional data structure that is a queue. Just keep on applying the level order traversal technique until you find a 0. If you find a 0, return a true, else just return a false. Based upon this idea, let us quickly do a dry run of the code so that you can understand how all of this is actually working in action. And you will also handle a case where we are encountering the same element again. For example, let us say I'm starting at this particular position. So you can go backwards and forwards. If you go backwards, you land at 3, right? Then once again, you will have two different conditions, correct? But what happened if you had taken one step forward? You land at 2. And now you once again have two choices. You go back 2 places or you go ahead. If you notice, we once again land at 3. So do you want to solve for it again? No, because that will end up taking a lot of time. So we need to account for it. You can check this in the tree as well. If you're starting at this position, you take two choices, either 3 or 2. When you are at 3, once again you take two choices. If you notice closely, this entire structure, this is repeated over here, correct? So you want to have a certain way that you are not traversing this entire tree again. And that is why the dry run of the code is really important and I want you to go over it. On the left side of your screen, we will try to build out the dry run of the code, and on the right, I have the sample array that is passed in as an input parameter to the function canReach. You're also passing off a starting index that tells me that, hey, this is the position I have to start, or eventually that will be my root node. Starting off with the dry run, what is the first thing that we do? First of all, we create a queue. Now, this queue will be used for your level order traversal. And the first thing that we do is we add the root to this queue. When I add this root, I am adding this start position to my queue. My start position is 5 and I add it to my queue. In the next step, I run a while loop that will perform my level order traversal. And for that, you will keep on iterating until your queue is completely empty. To start off with the level order traversal, you pop out a first element. So when you pop out the first element, you get 5. That means I am now experimenting with the index 5. So what do you have to do now? For every index that you're popping out, first of all, you have to check, hey, have I reached the target index? If the value at this index is 0, it simply means that, hey, I reached it and you can simply return a true, right? Otherwise, what do you have to do? You have to look in both the directions, correct? So you will try to first add the value and then you will try to remove the value. And if both of these are within the bounds, then you add both of these elements to your queue. So right now I am at position 5. So first of all, I will try to add one position. This gives me a 6. This is within the array bounds. So I will put 6 in my queue, correct? And similarly, you will try to go back and then add this index, that is 4. So 4 also gets added to your queue. So this is how you took care of this particular index, right? You have tried to traverse in both the directions and add it to your queue. So now you need to make sure that you are not coming back at this index again. And to make that happen, what I will do is I will mark this element as visited. To mark as visited, I will just make it negative. So what happens? Instead of 1, this becomes a -1. Now try to think what will happen once again. This loop will run and this time you are gonna pop out the next element and that is 6. 6 gets popped out, that means you are looking at this particular index now. So once again you check, hey, have I reached 0? No. And then you will try both the directions. First of all, you try to go in the right direction. You see that this is not within the array length. So you don't have to add anything. Now you will try to go back. So you try to go back 2 positions and you see that, hey, I am within my array length. So add this index to the queue. This means that once again, I will add 4 to my queue over here, right? Don't get confused by seeing 2 4s. You will quickly understand what I mean over here. Now you need to mark this element as visited since you have covered both the directions. So 2 now simply becomes a -2. And you have taken care of this current index 6. This loop will now run again. And this time you will pop out a new value and that is 4. So currently I am looking at this particular index. Once again you do the same things. You check, hey, have I reached a 0? No. So you will try in both the directions. First of all, try to go in the front. You cannot go 3 steps forward, so you don't do anything. You will try to go 3 steps backwards. This is within the array limits. So you will now add this index to your queue. You have added both the positions. So mark this element as visited. So 3 becomes a -3 now. This is where things get interesting. Now I iterate over this loop once again. What happens? You are done with this 4, but if you try to pop out an element, once again you get a 4. You do the same drill. First of all, check, have you reached the target index? No. But this time, if you notice, this element is negative. A negative value simply means that you have already visited this element, so you don't want to repeat things. So that is why we just add one additional condition. That means if this element is negative, just skip it. So I do a continue over here. That means all of these next steps will not be executed. This element will go away. And now I will run this loop once again and fetch my new index from the queue. So this is how this process will go on. This time I am at this particular index and I will try to go first in the front direction 2 steps and back in 2 steps. If I go in the front, I will get to add this position 3 in my queue. And when this loop will run once again, you will check this position 3 and ultimately you will return a true over here, right? So this is how, by using a level order traversal technique, you can determine if you can reach the target value 0. The time complexity of this solution is order of n because you iterate through every element only once. And the space complexity of this solution is also order of n because you need that extra space for the queue to store all of your elements. I hope I was able to simplify the problem and its solution for you. As per my final thoughts, I just want to say that it is always super beneficial if you just try to write down some test cases and sketch them out. Just try to visualize what is actually happening. For example, in this problem, as soon as you take up a specific index and then try to see where you can go, you will be able to arrive at the tree data structure, and that will definitely help you to arrive at a certain solution. if you just try to approach it using an array and try to make all of these manipulations, it can become a little tricky. You will agree to it, right? And I would also want to say that this problem is unrelated to Jump Game 1 and Jump Game 2, because this time the concept is entirely different. So I would highly doubt that this question can be asked as a follow-up question when you are solving one of the other two questions in an interview. So just a thought. While going through this video, did you face any problems? Or have you seen any other such problems which work on the same concept? Tell me everything in the comment section below and I would love to help you out of all of it. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This motivates me to make more and more such videos where I can simplify programming for you. Also, a huge shout out to all the members who support my channel. This really keeps me going. Do keep letting me know what other problems do you want me to solve next. Until then, see ya.